In this video, we're going to look at question 2 from Statics LO3 tutorial questions at the end of the course notes. Now, this is going to be quite a similar approach to the video for question 1 because we've been posed with a similar type problem in the sense that we have a single node, node B here, and we have one known force, the external force, and two unknown forces, the forces internal to the members. We're going to, if I take a similar approach, we'll have to be a bit more careful with our angles this time, but there's really nothing for us to worry about. Again, I'll name our spaces inside this structure, and outside of it is P, Q, and R. Just as a little reminder, this is space P because it comes from the edge of the structure all the way into the external force. Q is just the space that's internal to any triangle of forces in the wall there, and R is the space from the outside of the structure to the external force again. So between forces, there should always be a labelled space. And because we've got one node, we'll be doing our analysis of node B here. I should say we do have more than one node, we'll be 3 nodes, but one node which we have to work on because it has one known force, 12 kilonewton external force, and it has 2 unknown forces which allow us to do nodal analysis there. And then we're just going to sketch effectively the same diagram but without the any parts we're not using here. So we have 12 kilonewton force acting to the right, and we've got these 2 forces that are sloping towards that point. And we're told that if we were to measure from a vertical line here, this would be 60 degrees, and this one would be 30 degrees. And we'll make use of that in the diagram we're going to do next. We need to label our spaces again. So again, this is space P, space Q, and space R. And we'll label our external force based on the name of these spaces. So it's between P and R. So we'll call this PR. We'll label the next one that's got R in it beginning with R. So we're going to get a nice triangle of forces, RQ. And then we'll have QP over here. So that's the names of our 3 vectors. And you'll actually see, just by chance, this is the same way it worked out in the previous video in this topic, but there's no particular reason for that. Just different naming conventions. We could have labelled these spaces whatever we wanted, but I've chosen not to label them A, B, and C to avoid confusing them with the nodes of the same letter names. So we've labelled our spaces here. We're going to now begin to draw this into a diagram that's done to scale. This time we can see we've got a 12 kilonewton force, so I think it's probably quite sensible to say our scale could be 1 centimetre to 1 kilonewton, because that means that that first line we draw in will be 12 centimetres long, which we can fit in a piece of paper if we're doing this by hand. And as I've done in previous videos, I'll start off with a little crosshair just for, it's not so bad for our first vector, but for future vectors, always draw a wee crosshair in when we start drawing them off so that we can measure angles and show where our horizontal and vertical directions are. But this first one's going to be quite nice and easy. We'll start from the centre of this little crosshair, but we're measuring directly out to the right. And we know it's to the right because the arrow is pointing that way on the diagram we were given in the question, and in a complete horizontal. So I'll line this up here with the middle, and I want to draw a 12 centimetre line, and I'll use red for my first vector. 2, 4, 6, 8, 10, and 12. And that's acting out to the right. With external forces, it's okay to put the arrow on the vector itself. We'll never have a second node where we need to think about forces acting in both directions. I'll just put a little arrow there just now to show us where that's acting, and I'll label the ends of this as well. So this is vector PR, so going from P out to R. That's our first vector. So we need to add in now vectors QP and RQ. So vector QP is going to be something that's going to slope up through here, and vector RQ is going to slope at a different angle but come up through here. So they're going to meet somewhere either down here or up here, and that's going to form our triangle. But the way to find out where they meet is to draw them in accurately. So what we know about vector QP is that it has an angle of 60 degrees coming down from a vertical line. And we happen to have a vertical line here already in place at point P. So what that tells us, if we measure around 60 degrees from here, we can draw our line through where I measure 60 degrees to, and that will be accurate for the purposes of drawing in QP. So that angle in the question can be measured from any vertical line. It will be parallel to the line that we're looking at. And because it's going through point P, we notice this particular line. So this is what I'm measuring when I put this in with my ruler. I'm going to measure an angle here. I want to be careful with this because when you're doing this with the protractor, you just measure around 60 degrees. When I'm pointing up the way, it says 90. So I'm actually going to come round, and my ruler will say 30. I'll show you why in a second. But that's 30 above the horizontal, which is of course same as 60 down from the vertical in a right angle. So that's, don't be misled by what I'm drawing in here. I'll mark it on the diagram in a second just so you can see exactly what's going on here. I'll sketch in this line like so. We don't know what side of P the Q is going to be on. I suspect I know what it's going to be, but just in case, I sketch my line off in both directions. The reason my ruler is saying 30 is because this angle here is indeed 30 degrees, but this angle is 60 degrees, which is what I just measured there, which is what's the same as this angle over here. So that is what I've measured in to make sure that I've got the right direction. So I'll leave those little angles marked so you can see that how I've done that over here. Now over at point RQ, we're going to have a similar thing going on. We're going to have, if we do this in here, from 30 round, we'll have a line coming up like that. But I'm going to do this all properly. So I'm going to take my ruler to put in the little vertical line there. Now you can see in quite a lot of time, I'll do a full crosshair of horizontal and vertical, but here I know from what I'm measuring, I just need this little vertical line here, but it has to line up with the end of my vector. So I'm going to put this little sketched line here. And with the end of my vector as the center point of my protractor, I'd be measuring around 30 degrees from there. But as you can see again, on my ruler, it's showing 60 because 60 is the angle from the horizontal. And I'll sketch this in green. Now you can see that the two lines don't cross here. I've not made my blue line long enough, but that's fine. I can go and extend that. I can now see, looking, that the blue line and the green line are meant to cross somewhere. So I'll just readjust my ruler to line it up with the blue line. Line it up here, but I'm still not going to make them cross. I'll just have to shift up my page. And that's why sometimes we can be caught out doing these questions. And so you might need a bit more space than you think. So starting when you're not sure, when you're in the middle of your page, you've got a sensible thing to do. So I'll extend the blue line up here, but you also have to extend the green line as well. Definitely having enough room in the page is going to be quite useful. This is the point where they cross up here. So this is point Q. These two lines meet. So I can rub out any extra lines we have that are outside of where our forces all join each other, because these were just drawn in to help us find where the blue and green lines met. But now we know they meet. Everything else is not required. So we now have our triangle PRQ that we have here. Now we know we're going from P to R because that was given to us in the question. We're pointing to the right there. We must be heading up from R to Q and from Q back down to P. So we can translate these over to our little node diagram. So RP, so RQ rather, the green line is pointing up the way. So it means that RQ is pointing towards the node, and QP is pointing down the way, so this is pointing away from the node. So we can say something about the nature of our members here. So we have the member, we have the force, which we'll get to in a second, and we have the nature. And we'll just go with the names I've given them. So I have a member called RQ, representing the member joined by nodes B and C. So I'll put this in the bracket here. This is nodes B and C. And I've got a member QP, which represents the member joined by nodes A and B. So RQ, I can see is pointing towards the node. If it's pointing towards the node, that means it's a strut. And similarly, because QP is pointing away from the node, that means it's a tie, it's under tension. The internal forces will be doing the opposite of the external forces of a member's being pulled upon under tension. Its internal forces must act in the way to counteract that. So we've determined the nature of both of these. The last thing that remains is to measure them. So the ruler's currently lined up along RQ, so I'll measure this one first. 2, 4, 6, 8, 10, 12, looks like 12 centimeters there. So I've got 1 centimeter to 1 kilonewton, an easy one to work out. This must be a 12 kilonewton force. And then I'll measure along blue line, QP, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It looks like 20, just over 3/4. My ruler unfortunately doesn't work in millimeters. So just over 3/4 is 20.8 centimeters. So 20.8 centimeters using our scale is 20.8 kilonewtons. And that's only because our scale is 1:1. If it was some other scale, I couldn't just write down the value in centimeters. It's only because 1 centimeter is 1 kilonewton. And that concludes question 2 from learning outcome 3.